Hello students, this video we're going to be talking about section 1.6 exponential notation. So an exponent is the number of times a factor is multiplied together. We can consider exponentials the same as repeated multiplication. So for an example here, we have 2 to the 5th. This is written in exponential notation. This has a base of 2 and an exponent of 5. It's really important to be able to differentiate between those two terms. So the base is 2 and the exponent is 5. When we expand it, it becomes 2 times 2 times 2 times 2 times 2. This is expanded form because we can now see every part of this exponential. This is exponential form. This is expanded form. Our final test is to see if we can simplify this. And to simplify simply means to perform the multiplication. So this is expanded form. And to complete this, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So, exponential form, expanded form, and this is the numerical value. This is what we want when we say simplify. We can have examples of these with more than one factor as well, more than one base. 2 is a base as well as a factor in this. Here's an example. We have the expression 2 to the 3rd times 3 times 5 squared. So in this one I have 3 bases. I have a base of 2. The exponent on this base is 3. I have a base of 3. The exponent on this one doesn't appear. Well, when this doesn't appear, we assume that it's a 1. And we have a base of 5 with an exponent of 2. So remember that a base looks like a number as we would write it normally. The exponents are the smaller numbers up above. If there is not one present, that means we assume it's a 1. So to write this exponential notation into expanded form, I would write 2 3 times. I have a single 3, and I have 5 2 times as well. Oops. Okay, so here's our expanded form again, where we're seeing everything, we're being able to view every part of this, and then we're going to simplify this by doing the multiplication. 2 times 2 times 2 is 8. 8 times 3 is 24, and 5 times 5 is 25. So when I multiply those two things together, you can do long multiplication, which is fine. Four times 5 is 20, carry the 2, 5, 2, 10, plus 2 is 12, 0, 2 times 4 is 8, 2 times 2 is 4, I get 600. Okay, so that's the simplified version of this exponential expression. I'm going to give you a few practice problems. Once I write them, please press pause on your computer, try to work them out, and I'll give you a pause in here, and then I'll give you the answers so that you can check your work. have 3 problems here for you. It's good to practice writing them both in expanded form and then to simplify and get that number answer. So the first one I'd like for you to try is 2 squared times 3 squared. The second one I'd like for you to try is 5 cubed, or to the 3rd power, times 7. And the third one is 4 cubed times 10 squared. Okay, write those down. I'll give you a minute. Pause the video so that you can work those, and I'll pick back up in just a minute. Okay, hopefully you paused the video and were able to find what these numbers were when we simplified them. I trust that you did the expanded form on your own, but your answers should give you 36 for number 1. Number 2 is 875. And number 3 is 6,400. Okay. All right, I have one more note in this section for exponentials, and if you didn't get any of these, please ask questions at the beginning of class so that we can talk about why something may have been different than what you were getting. My final note about exponential is that if we have a power of 10, it makes things a lot easier for us when we're multiplying. The pattern goes like this: 10 to the 1st is 10. Obviously, anything only one time is that thing. 10 to the 2nd, 10 times 10 is 100. 10 to the 3rd, a 1,000. The pattern's going to continue. I'll show one more, and then we'll talk about what the pattern is. The exponent that's showing up on each of these is the number of zeros that ends up in our final answer. We can use this to our advantage to do calculations very quickly. Anytime you multiply by a power of 10, you are essentially tacking a 0 onto the end, or that many zeros onto the end. So the example that I have here is if we're going to do 6 times 100, what I do is this number, 6, times this number, 1. And then I had 2 zeros. So I'm going to have 2 zeros again. This is pretty intuitive that 6 times 100 is going to be 600. But this works in other situations as well. If we have 4 times 40, I'm not going to count 40 4 times or 4 40 times. I'm definitely not going to do that. But what I can do is 4 times 4, which is 16, and I had a single 0, which comes along. 4 40s is 160. Okay. The third example that I'll do of this is 50 times 70. To show you that it's not only when there's zeros in one place. We can do this for as many as we have. Instead of doing 50 times 70 or 5 times 70, what I'm going to do is 5 times 7. I know that that's 35. And I had a 0 on each, which means I had 2 zeros. So this is a little shortcut that will help you do some mental math and not have to write out long multiplication for a lot of things. If we have anything times a power of 10, that makes our lives easier when we're doing the multiplication. Okay. See you next video.